It's chemistry and you are watching Grand Science.
In this video, we will learn what is an electrolysis and we will have a short introduction to electrolysis. Then we will see what is the structure of simple electrolytic cell. We will learn about the electrolysis of some molten compounds with good examples, and we will also learn how to write half equations at cathode and at anode. If we understand the meaning of the term electrolysis, then the word electrolysis, lysis means breaking down, and electro word is breaking down with the help of electricity. So we'll call this electrolysis is what? It's the breaking down with the help of electricity. Now, any liquid that contains ions is going to conduct electricity, and that is the reason what can we break down with the help of electricity is the compounds or the liquid which contains ions. Now what is that? That's the only ionic compounds which can be broken down with the help of electricity, because ionic compounds contains ions, charged particles. Covalent compounds does not have. So covalent compounds cannot be used for the electrolysis, but ionic compounds can only be used, and that also only in the molten or aqueous form, because in only molten and aqueous form the ions are free to move. And if ions are free to move, then only the electricity will be conducted, and that's why ionic compound in molten or aqueous form is taken for the electrolysis. The important components of electrolysis, that is, what are the things which we require for electrolysis, is first electrodes. Electrodes are what? They are the rods which conducts the electricity. They are anode and cathode. And it should be made of the material which can conduct electricity. So they should be good conductor of electricity, and they should be inert also. Why? Because they should not themselves participate in the electrolysis. Electrodes should not participate. The reason being is that the ionic compound which we are using, that will only undergo breaking down. So electrodes are not allowed to participate, and that's why we need them inert, and that's why we use generally graphite electrodes which are even cheaper, or we can even use platinum electrodes which are good conductor, as well as inert metals. Other metals cannot be used because then they will also participate. They are not inert. Now electrolyte. Electrolyte is a liquid which conducts electricity. So here what are we taking electrolyte? We are taking ionic compound in aqueous or molten form as an electrolyte. That's the only thing which we are allowed to use as an electrolyte. Now what is an electrolytic cell? That's the vessel or the container in which the electrolysis is carried out. Vessel or a container. Now other than that, we need power supply also. Now power supply can be the mains power supply, or we can even use batteries if we are conducting electrolysis at a small scale. Now let's have a look at the structure of simple electrolytic cell in which electrolysis is carried out, and let's start first with the electrodes. The first one here, I'll label that as a cathode. That's because it is connected to the negative terminal of the battery, and because it is connected to the negative terminal of the battery, so cations gets attracted to the negative terminal. Cations are positively charged, and so it's get discharged at the oppositely charged terminal, that is the electrode, and that's why I call this electrode as cathode. The second rod is called as anode, that is connected to the positive terminal of the battery, because the anions which are negatively charged ions will get attracted to the oppositely charged terminal, that is the positive rod, and that's why such a rod where anions gets attracted, gets discharged, is called an anode. Next is electrolyte. Now electrolyte, as we already seen, is the liquid that is ionic compound in molten or aqueous form. And then at the last we have electrolytic cell. That's the container which helps us to carry out the electrolysis. Yes, we are left with the power supply, that is battery or the main supply through which we can supply some electricity. So these are the main components of electrolytic cell electrolysis, which is required for conduction of electrolysis. Now let's understand some more important points here. Is that electrons flow from anode to the positive terminal of the battery, and then electrons flow from the negative terminal to the cathode. Now there is a difference. Anode, electrons flow from anode to the power supply, and for the cathode, electrons flow from the power supply to the electrode, that is cathode. That's the main difference between anode and cathode, the direction of the electron flow. So you can say that electrons flow in the external circuit. But what about the rest part of the circuit? Here in the electrolyte, the ions moves to the electrodes of the opposite charge, and this is how the circuit gets completed and the current fully flows through the circuit, and this is how the electrolysis is conducted. Now let's understand the electrolysis of one of the most common molten compound, that is lead bromide. Now lead bromide is PbBr2, which on conduction with electrolysis, it decomposes into its elements, that is lead and bromine, and here is an overall reaction. But during electrolysis, what happens? The lead bromide, which is taken into container, that has to be heated, and when it gets heated and changes into ions, then this ions split up and starts moving through the molten electrolyte, and that is how the electrolysis starts. So there are lots of such lead and bromide ions which are there in the molten electrolyte, and when the electricity is passed through it, then the bromide ions move towards the anode. Now what happens is this bromide ion loses electrons, and this electron passes through the external circuit towards the mains or the power supply, and here when bromide ion loses the electrons, it changes to bromine element, that is the molecules of the bromine element, and that's why we can see that there are certain vapors of the bromine element being formed at the anode. So we will see lots of bromine, red-brown vapors being involved at the anode. So at anode, the bromide ions undergo oxidation to form the bromine molecules. Now here we call it as oxidation because the bromide ion loses electron, and as we have already seen in our earlier video of redox, that losing of electron is oxidation. So at anode always oxidation occurs. Now what about the lead ions? Lead ions moves towards the cathode, and the electrons from the battery or the power supply moves towards the cathode, and these electrons are gained by the lead ions to form the lead metal. Now lead metal is a silvery metal, so it will be seen as a silvery deposit on the cathode. So at cathode, the lead ions accepts electrons from the power supply, undergoes reduction to form the lead metal, that is lead element, and this is how the electrolysis occurs, where an ionic compound lead bromide is being decomposed into its elements lead and bromine, lead being formed at cathode and bromine being formed at the anode. So you can always say, summarize this, that ionic compound always contain a metal and a non-metal. Metal would be formed at cathode and a non-metal will be formed at an anode. This is fixed. So at anode always oxidation occurs, and at cathode always reduction will be occurring, because the metal ion will accept electrons to form the metal element. And here you have seen two observations also. One of the observation is formation of red-brown vapors of bromine at anode and a silvery deposit of the lead metal at cathode. So these observations might vary from one to the other molten compounds. And the important part is that the electrolyte, which is lead bromide, electrolyte will get used up. So as the metal being formed at cathode and non-metal at anode, the electrolyte will keep on getting reduced in amount. It will keep on getting used up. And this is always going to occur with any of the molten compound electrolysis. Now here are the examples of many more electrolysis of other molten compounds, ionic compounds, and you can see the products at cathode and at anode. You can always pause this video and have a look, but you can summarize that at cathode always a metal is forming, and at anode always a non-metal is forming, which is present in the ionic compound. Now what is the important part? Let's learn how to write the ionic equations of all these compounds, because that is very important from the examination point of view also. So first let's study about the half equations, half reactions at cathode and at anode. So first is the sodium chloride, and at cathode what is forming? Sodium. At cathode what gets discharged? Sodium ion. Sodium ion is going to gain one electron. Why? Because it has one positive charge, gains one electron to form the sodium element, sodium metal at cathode. Next, it's going to form chlorine at anode. Chlorine at anode is going to get discharged at anode. Now that is going to lose electrons to form the chlorine element molecules. So here electrons should be lost, but as we can see it is Cl2, two chlorine atoms combine to form the chlorine molecule. So two chloride ions are needed, so we balance it. So here two electrons should be lost. So this is the balanced half equation at anode for sodium chloride. Next, let's write the same things at cathode half equations for copper bromide. Now at cathode obviously the metal copper will be formed. So copper ions are discharged at cathode. They are going to gain two electrons to form the copper metal. Two electrons needed because it has a 2+ charge. So two electrons being gained by the copper ion to form copper metal. Now at anode, here bromine is going to form. So bromide ions are discharged, forms bromine molecule. So balancing again requires 2 here with the bromide ions, and so it loses 2 electrons. So oxidation again occurs at anode and it loses 2 electrons because 2 bromide ions are required to form 1 bromine molecule, and 1 bromide ion loses 1 electron each. So altogether 2 bromide ion loses total of 2 electrons. Next, let's try for zinc iodide. Now again zinc will get discharged at cathode, the zinc metal, and it is 2+ charge. So again it will require 2 electrons to form the zinc metal at cathode. Next at anode, iodine is being formed. So to form the iodine molecule we require 2 iodide ions which will get discharged. 2 iodide ions form 1 iodine molecule losing 2 electrons because 1 iodide each will lose 1 electron. Next is aluminium oxide. Now aluminium here again will get discharged at cathode. Now aluminium is 3+ charge, so it will have to gain 3 electrons to form the aluminium metal. So number of electrons being gained depends on the charge of the metal ion. If it's 2 plus charge, then it has to gain 2 electrons. If it is a 3 plus charge, it needs to gain 3 electrons. So at anode, what is being formed is the oxygen. So if oxygen is being formed, then the oxide ion, which is 2 minus charge, that is going to get discharged and form the oxygen molecule. So again, if we balance it, we require 2 here. Now here, one oxygen ion loses 2 electrons. So if 2 oxygen ions are being used, a total of 4 electrons are being lost. So here you can simplify it by multiplying this number with the charge. So that many number of electrons are being lost, and this is how you make the ionic equations at cathode and at anode for any of the molten compounds. Only thing you need to remember is that the metal ions will get discharged at cathode, forming the metal. Anions, that is non-metal ions, will get discharged at anode, forming a non-metal at the anode.